So far in this course, we've only discussed and worked with digital audio. However, before digital audio existed, there were analog recordings. Analog audio is a direct representation of the sound, like a groove cut into the vinyl of a record, or changes on a magnetic tape. Note I'm wearing my cassette tape earrings today in honor of this lecture. Digital audio is a numerical representation of the sound. It's a series of zeros and ones stored on a medium. Analog signals are continuous, with no space between the sound, while stored digital signals are discrete, with gaps between the sound that software and hardware interpret to create a smooth output signal. In order to get sound into a computer, we sample the sound, or take a picture of the sound pressure level. The sampling rate is how many times per second we take a picture of the sound. And this is done with an analog to digital converter, an ADC. The more samples there are per second, the smoother the signal will look. The sampling rate for CD quality audio is 44.1 kilohertz. We already know that K stands for kilo, which means 1,000. The sampling rate for CD quality audio is 44.1 kilohertz. So kilo means 1,000, so we're sampling 44,100 times per second. For comparison, the sampling rate for films is 24 frames per second. So why do we need 44.1 kilohertz samples per second? So remember that the range of hearing is 20 to 20 kilohertz. Think about what would happen if we sampled a 20 kilohertz sound 20,000 times per second. We'd get basically a straight line. Remember, a wave has to go back and forth during its wavelength. In this slide, the blue line represents the original signal, while the red line indicates the result of a sampling rate which is too low. If we sample a high frequency with a low sampling rate, we'll hear a lower frequency than the original signal, and this is called aliasing. It also happens in film. Watch an old movie. The stagecoach wheels appear to be going backwards very slowly, because the wheel completes more than one rotation between each frame. Therefore, we must sample at a rate twice that of the highest pitch we want to hear. And before the analog to digital converter, we have to put a low-pass filter to remove any signals higher than the sampling rate. There are some audio engineers using a 96 kilohertz audio rate, but for this class, CD quality is fine. So if the picture that we take of the sound is just a binary number, and the number of decimal places we use to record the sound pressure level is actually called bit depth. CD quality audio has a bit depth of 16. Again, there are engineers using 32-bit sound. This helps tremendously with the noise floor, but then most recordings are truncated to 16 once they're bounced to save room. Old video games didn't have enough processing power to do 16-bit audio, so they used 8-bit, and it's a distinctly crunchy sound. There are bit crusher distortions which truncate the sound, and my friend Tristan Parrish even wrote an entire album using 1-bit audio, and I'll put his YouTube link in an announcement. So, we use an analog to digital converter to get sound into a computer, and to get sound out of a computer, we need a DAC, or digital to analog converter, which converts a fixed-point binary number into a physical quantity, such as voltage. Another way to say this is that the DAC is used to convert discrete time series data to a continually varying physical signal. Just as an ADC has to have a low-pass filter, the DAC needs a reconstruction filter. The sequence of voltage impulses are processed by a reconstruction filter using some form of interpretation to fill in the gaps between the impulses. In this way, the stored digital audio becomes analog audio. If you record a digital recording using analog devices, you won't be able to detect the samples. The signal is just as smooth as any analog recording. It's just been low-passed. In the forums, I'd like you to discuss the merits and drawbacks of each kind of storage, analog and digital.